So this video will give an overview of Chapter 1 for the Math 141 class. So Chapter 1 deals with equations of a straight line. So first bit in terms of graphing. So if I have a point, so let's say this is the point 2, 2, and then I have a second point, and let's say the coordinates of this point is going to be 6, 7. Right? So I have my 2 points. So again, remember in terms of coordinates of point, the first number is the x, the second number is the y. And again, just for a bit of a quick review, this is my x-axis, and then this is the y-axis. So we want to be able to find out what is the distance between these 2 points. And so we want to know how far is it to go from 2, 2 to 6, 7. So we want to get that value. Right? So the way we can get that is a thing called the distance formula. And the distance formula is just a variation of the good old Pythagorean theorem. So in terms of my example here, so let's call this the point x1, y1. We'll call this the point x2, y2. And so the distance in between my 2 points then, d is going to be, this is going to be 6 minus 2 squared plus 7 minus 2 squared. So this is going to be 4 squared plus 5 squared. So this will be the square root of 16 plus 25. And we get the distance is going to be the square root of 41. Right? So that is my distance between those 2 points. Right? Well, the other thing then we can also find out in terms of where is the midpoint. So if I think now in terms of having a segment that connected these 2 points, so here, I want to know basically what would be the coordinates of this point right there, which would be in the middle of those 2. Right? So the way I can do that is, well, the coordinates of the x midpoint is going to be x1 plus y1 over 2, and then y midpoint is going to be x1 plus x2, sorry, this should be x1 plus x2, right? And then this will be y1 plus y2 over 2. Right? So in terms of my example then, this is going to be 2 plus 6 over 2, which will be 4. And this will be 2 plus 7 over 2, which will give me 4.5. And so the coordinates of my midpoint is going to be 4.5. So we have our distance formula and we have our midpoint formula. Well, other things you can do given we have a couple of points. So let's say we now have these points 4, 7, 8. Let's call this 17. Right? We can find the slope, and slope is rise over run, or the change in y over the change in x, or in terms of an equation, y2 minus y1 over x2 minus x1. So again, if I call this x1, y1, and we'll call this x2, y2, we can calculate our slope. And so the slope is going to be 17 minus 7 over 8 minus 4. So this is going to be 10 over 4, which will be 5 over 2. So in terms of slope, we're going to leave it in terms of that fraction, that improper fraction. Okay. So we'll leave slope in terms of that term. Again, if it comes out to be a nice whole number, then we would leave it in terms of a whole number. Otherwise, we would leave it in fractional form, like we have here. So we can have in terms of our slope of our line. Okay. Right. So we have slope equation. Okay. So then we get to, well, what is an equation of a line? And there are several ways of writing that. Okay. And so go through those. So one way is in terms of the point slope form, which is y minus y1 equals mx minus x1. And when the equation is in this form, m represents the slope, and x1, y1 is the point on the line. Okay. And then the other way we can write this is in terms of the slope-intercept form, which is y equals mx plus b form. And here, m again is the slope, and b is the y-intercept. And then lastly, the other way we can write an equation of a line is the general form, which is ax plus by plus c. Ax plus by is equal to c. And those are the three ways. Generally, you're going to have it in terms of point slope or slope intercept form for an equation of a line. So how do I write these? So again, let's go back and pick a couple points here. So let's do this. So let's say we have 4, negative 3, and 6 minus 12. So we want to come up with the equation of a line that goes through these points. So one way of doing that now, first is, well, we need to know a slope. So my slope, and again, let's call this x1, y1, x2, y2. And so my slope is going to be minus 12 minus a minus 3 over 6 minus 4. So minus 12 minus a minus 3, remember 2 negatives makes that a positive, and so this is going to be minus 12 plus 3, which is going to give me a minus 9, 6 minus 4, which is going to be 2. So my slope is a minus 9/2, right? So let's write my equation in first point slope form. So we have our slope, which we got, and we could then take our point, which was the 4. So we got m is a minus 9/2. We have this point. So this is my x1, this is my y1. And so we get y minus a minus 3 equals minus 9/2 x minus 4. And of course, this will just become y plus 3 equals minus 9/2 x minus 4. So we have our equation in that form. We could have if we wanted, because again, we said x1, y1 is a point on the line. But in this case, we also know that the other one is also on the line. And so we could have taken this point. And again, plugged in. So this would be y minus a minus 12 equals 9/2 x minus 6. So y plus 12 equals minus 9/2 x minus 6. So we could get that form too. Right? So that is how I get point slope form. How do I get it into the slope intercept form? Well, let's do that with the one we just did. So what I'm going to do is we're going to take the y plus 3 minus 9/2 x minus 4 and rearrange into y equals mx plus b. So what that means, I'm going to take the equation I have and I'm going to solve it for y. Right? So this is going to be y plus 3 equals a minus 9/2 x minus 9/2 times a minus 4 is going to give me a positive 18. And then we just need to take the 3 over. And we end up at y equals minus 9/2 x plus 15. And we now have it in the other form. Right? So we can go from one form to the other. So we have in terms of our writing the equation of a line given 2 points. Right? Now, other things then, in terms of our line and our properties of our line, is we can note in terms of whether or not there's any kind of symmetry in an equation. Right? Right? So we look in terms of symmetry elements, right? Of an equation, right? So what I know is they're going to be symmetrical, and there's going to be 3 types of symmetry, and so it's going to be regards to the x-axis, in regards to the y-axis, and then in respect to the origin. And the way we do this is that this equation is we're going to replace y with negative y, and the y-axis we replace x with negative x, and then with the origin we replace x and y with negative x and negative y. So how do we tell whether or not something like this works? So let's do some examples. So first off, with respect to the x-axis. So let's say, for example, I have x equals 5y squared. Is my original. So now the question is this going to have symmetry with respect to the x? So what we do is we replace the y with negative y. And so negative y squared is going to give me 5y squared. And those two equations are the same, so yes, it is symmetrical with respect to x. So for the y-axis, so now if I have something like this, y equals 3x squared, right? Now, again, I'm just going to replace x with negative x, and so now y is going to equal 3 times negative x squared. So y equals 3x squared. And again, those are the same. So this is symmetrical with respect to the y-axis. Right? And I should make this with respect to the x-axis. And then the other one is the origin. And so let's use this for an example. Y equals x cubed. Right? Right? And so now this says replace both. So negative y equals negative x cubed. So negative y equals negative x cubed. And then, of course, I could divide everything by negative 1. And y equals x cubed. And again, those are the same. So this is symmetrical with respect to the origin. So those are the 3 symmetry tests you can do with an equation. Right? So, and going back in terms of our lines, right? So we got in terms of, back to our lines. So we got lines and slope. Let's go a little bit more about slope of a line. So let's draw some lines here. So I could have a line that goes like this, and this one would have a positive slope. But if you go from left to right, you're going uphill. I could have a line that's going like this. This one has a negative slope. This again, when you're going from left to right, you're going downhill. You could have a line that's going like this. So this has no slope. And then you could have a line going like this, which has infinite or undefined slope. So a line that has no slope would be something that's going to be in this form. Y equals A, where A is some number. And then one that has undefined slope would be something in this form. X equals B. Okay, would be those two. Okay. Well, how about parallel lines and perpendicular lines? How about those two cases? Well, parallel lines. Well, the thing that makes parallel lines parallel is that they have the same slope. So, for example, if I said, what is the equation of the line is parallel right, to y equals 3x plus 4 and goes through the point 5, 2. Well, I look at my given equation, y equals 3x plus 4, and I can look at it and say, okay, well, the slope of that line is 3. So the slope of my parallel line also has to be 3. And we have a slope, we have a point, and so I can say, okay, y minus 2 equals 3, x minus 5. And then I could rearrange that into the other form. 3x minus 15, and take the 2 over. And we end up at y equals 3x minus 13. So we have the equation on my parallel line. Well, how about perpendicular lines? Well, perpendicular lines, right? So let's draw a graph, what happens with perpendicular. So if I have a graph, I say, okay, graph my line. So let's graph a line. So let's have a line going like this. Well, this line has a positive slope. Okay? Well, perpendicular lines, when they cross, meet to form a right angle. So that would mean this line is going something like this. So this one is going to have a negative slope. And so for perpendicular lines, you have that the slopes are negative reciprocals. So let's do the same point we had here, but now let's find in terms of perpendicular. And so we had y equals 3x plus 4, and we had the point 5, 2. But this time I want the perpendicular. Well, the slope of my given line is 3. So my slope of my perpendicular line is going to be a negative 1 over 3. Right? Again, remember 3 is the same thing as 3 over 1. So the reciprocal part, I just take my fraction, I flip it over, and then I change my sign. So I get that. So now I get y minus 2 equals negative 1/3 x minus 5. And then again, I can rearrange this. Y minus 2 equals minus 1/3 x plus 5/3. And bring the 2 over. And remember, to add or subtract fractions, we need to have a common denominator, which in this case will be 3. So this is the same thing as 6 over 3. And so we end up with y equals minus 1/3 x plus 11/3. And we have our equation of that. So a bit on lines, right? And then the last section of this chapter finishes off with a bit on circles. An equation of a circle. Right? So we can first look in terms of having a circle that is centered about the origin. So barely here, right? So the equation here is going to be x squared plus y squared equals r squared. Right? Is that equation. Right? But then if I have my circle located someplace else other than the origin, so now let's draw another one. And so now we have my circle And let's say it's now over here, right? And so now we get x minus h squared plus y minus k squared equals r squared. So when the equation is in this form, hk tells you the center, point of the circle, center of the circle, and r is the radius. So for example, then if I had something like this, x minus 3 squared plus y minus 5 squared equals 81. Well, the center of my circle is going to be at the point 3, 5, and the radius is going to be 9. So we can get in terms of that, right? So given an equation like this, can you tell me what the center and the radius is? And then the other thing is, given that the center is minus 2, 3, and r is equal to the square root of 17, can we write the equation? So go and so here we would have x minus a minus 2 squared plus y minus 3 squared equals the square root of 17 squared. So this becomes x plus 2 squared y minus 3 squared equals 17. And so we can get that. Okay. So that is sort of a brief overview of some of the equations you'll see in terms of this first chapter. Okay. Sort of a brief summary. And you'll see more in terms of what's involved in that. But really you have in terms of what we went through here for today. So we had in terms of distance formula. We had in terms of our midpoint formula. Formula for finding the slope. General ways of writing an equation of a line, point, slope, slope, intercept, general form of a line, and being able to come up with that. Okay. Symmetry of an equation, x, y, and origin. And then in terms of slopes, types of slopes that there are, parallel and perpendicular lines, and what makes those true. And then finish it off with our equations of a circle centered at the origin and then centered at some other point other than the origin. And that will conclude this overview video.